So welcome back. So now that we have logged in, let me show you how we can create a very simple circuit. Okay, just to show you how powerful and how intuitive this platform is. All right, so to get started, all right, on the right hand side you can see this plus with the create button here. So click on this create, and again we can do 3D design, we can do circuits, we can do code blocks. All right, so I'm going to focus on circuits. So let's go and create a very simple circuit here. Okay, so once you click on circuits, it will open up the platform. All right, and what you see on the right here are a list of components normally used in very basic circuit design, things like resistors, LEDs, push buttons, batteries, all right, motors, transistors, and so on. Right. Okay, so these are things, of course, that you would be familiar with if you have already been involved in STEM based workshops or classes, robotics, basic Arduino Unos, and so on. Right, so let me give you a taste of what you can do here in TinkerCad. So let's build a very simple circuit with a battery and resistor and LED. So I'm going to bring out this 9-volt battery here. Okay, and after that I'm going to bring out, okay, so before that let me just flip this. All right, so flip this a bit here, vertical. I'm going to bring out a resistor, and I'm going to bring out an LED. All right, now what I want is to very simply create a circuit that lights up the LED. So for that I must create a closed loop from the positive of the battery through the resistor, through the LED, and back. Okay, now for an LED there are two pins. Okay, so if you see, there is a cathode and anode. All right, physically, if you look at any LED, the longer leg will be the anode, the shorter leg will be the cathode. All right, so of course once you cut the legs it's a bit difficult to see, so you need to test it using a multimeter. All right, so now here what we need to do is we need to make sure that the current, or for LED, always has to flow from the positive to the negative. Okay, then we call it a forward bias operation of the diode, which will allow the LED to light up. All right, so again, if you don't quite understand that, don't worry. Okay, this is a bit more electronic stuff. As long as you know that current has to go from anode to cathode, that is the important thing, because if I connect it the other way, LED will not light up. All right, so to make it seamless with the current orientation of the battery, I'm going to flip the LED. So flipping is this button here, mirror. So what I'm going to do is very simply connect wires. So to connect wires, you just move your mouse to the pin, okay, that you are interested to start a connection with, and you click and drag it to the next component. All right, here, here, and back here. All right, so this is what we call a closed loop. All right, so for current to flow, there must be a closed loop. Closed loop means there must be at least one single path from the positive of the supply through the components back to the negative of the supply. All right, so to see the LED light up, we can start simulation. All right, and you can see that the LED lights up. Okay, so just to illustrate the point that I made just now about the positive and negative, if I flip it now, if I flip it and if I try to connect, all right, and if I run it, you can see that the LED does not light up. All right, so the correct way of connecting an LED would be such that the current flows from the positive to the negative. All right, now just to make it a bit more better, I'm going to add a push button switch. Okay, so a push button switch, okay, in this case there are 4 terminals. All right, and the way we connect is usually diagonal. So what we can do is we can connect a wire here and diagonally this way. Again, the orientation and the behavior of different switches can vary. All right, so when you get a physical push button switch, please use a multimeter to test how the pins are connected, then you will know how to do the physical connection on a breadboard. Okay, so now if I run the simulation, okay, you can see that the LED does not light up until I press the button. Okay, so when I press the button, then the closed loop is formed and current flows through the LED. Alright, so this is just a very basic introduction to show you how TinkerCad can be used in such study and learning of electronic circuits. Alright, so moving forward, okay, we're going to explore more circuits and start off with the Arduino learning material. Alright, so that you can learn how to program the Arduino very effectively just using TinkerCad alone. Alright, thank you for watching. I'll see you soon in my next video. Bye.